Okay, let's do those Lewis dot pictures this time for covalent compounds. Now remember, covalent, share, covalent, share the valence electrons. Both of these nonmetals want electrons, so they're going to find a pair, at least, that they can share. Think, have a pair, can share. Our first example is between chlorine and chlorine, Cl2. So if you have a chlorine and another chlorine atom, each of those chlorines have 7 valence electrons. Let's write them down individually and see if we can find any pairs we can share to make our octet. So chlorine has 7. 1, 2, 3, 4, 5, 6, 7. The other chlorine, because we have 2 of them, has 7. 1, 2, 3, 4, 5, 6, 7. We're going to look for pairs we can share because this chlorine is not complete, does not have its octet. It needs one more. This chlorine is also not complete. It has 7 valence electrons. It needs one more. However, if they decide they can share these 2 right here, I'm going to redraw this in a different way. If we redraw it where the pair is shared equally between them, equidistant. Remember, think of a box around each element. So we've got each chlorine, then they still have these other electrons on the outside. Well, in this case, each chlorine will have 8 around it. 2, 4, 6, 8 for the chlorine on the left, 2 in the middle, 4, 6, 8 for the chlorine on the right. Both of them have completed their octet. Now, the name for these pairs is a little different. There's 2 different names depending on the type of pair that you see. The pair right here that's being shared, well, that makes sense, is a shared pair. Or a shared pair is a covalent bond. So we've made a covalent bond. These pairs of electrons, we have a pair, 2 on top, 2 on the left, a pair on the left, and a pair, 2 on the bottom. Those pairs of electrons have a different name. They are called lone pairs of electrons. Those are not being shared, but they're very important also for the geometry, shape, polarity, the way these molecules interact. Those lone pairs are also equally important. So this is one way that you could draw your answer for a covalent molecule, and we call that a Lewis dot picture. Now, I kind of like the line pictures a little better though. So another way that you can draw your answer is we have the chlorine and we have the chlorine, but instead of drawing 2 dots for your shared pair, we can draw a line to represent the covalent bond or the shared pair. You still have to draw the dots on the outside, 2, 4, 6, and 2, 4, 6. You have to do the lone pairs to show that everything has 8. Remember, a line really represents 2 electrons. So this chlorine on the left has 2, 4, 6, 8 electrons around it. The chlorine on the right has 2, 4, 6, 8 electrons around it. So each of those chlorines has its octet. Let's go ahead and try another one. What if I asked you to show me the Lewis picture, the Lewis structure for water? All right, let's start at the beginning. We have 2 H's and we have an O. I'm going to go ahead and start with my oxygen. Oxygen is in the oxygen family and has 6 valence electrons. 1, 2, 3, 4, 5, 6. Then we're going to bond that to hydrogen. Hydrogen has 1 valence electron each. So hydrogen gets 1 valence electron, and I have another hydrogen with 1 valence electron. And I start looking for pairs that I can share. So I see that these 2 can double up and be shared, and this oxygen can share its valence electron with hydrogen on the bottom. If I do that, I could redraw water as a dot structure with 2 dots, not 1, 2, left, right, but top and bottom, like again, we're completing a square around oxygen. And then we have hydrogen. On the bottom, we have 2 dots and hydrogen here. Now, oxygen has completed its octet. It has 2, 4, 6, 8 around it. Hydrogen, being the smallest atom of all, only gets 2 electrons around it. The first shell is full with 2 electrons. So don't ever try to make hydrogen have more than 2 electrons. This is complete, and that's a good Lewis dot structure. If I draw it with lines, which I prefer, oxygen still has 2 lone pairs, a lone pair top, a lone pair on the side. It has a single bond to hydrogen and another single bond to hydrogen. Oxygen has 2, 4, 6, 8 electrons around it. All right, let's try one more. Let's try ammonia, NH3. So nitrogen is a nonmetal. Hydrogen is also a nonmetal. We're going to get a covalent compound where we share valence electrons. So nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. It looks like it has 3 places that it needs partners. Well, okay, hydrogen. We have 3 hydrogens to put on there, so that's super convenient. So hydrogen has 1 valence electron. We have a pair we can share. Hydrogen has 1 valence electron. We have a pair we can share. And hydrogen has 1 valence electron. We have a pair we can share. Dot picture would look something like this. A nitrogen with 2 electrons, top and bottom, equally distant between nitrogen and hydrogen. 2 electrons with a hydrogen. And then 2 electrons with a hydrogen. Or you can do the lines. Nitrogen, lone pair, line to hydrogen, and a line to hydrogen. All right, I hope that helps. Take care.